Okay, we're going to talk about rationalizing. When we're talking about rationalizing a denominator, it's when we have a root in the denominator. And we don't want the root in the denominator. So for example, if I give you 5 over the square root of 2. Well, we don't want the square root of 2 to be in the bottom. So we do this tricky thing to get rid of the root in the denominator. So what we do is we multiply by 1, because multiplying by 1 doesn't change the value of anything. It does, however, make the thing look different. It won't change the value. It's kind of like how if I were to write the date as 5/6/2020 as opposed to May 6th, 2020, right? I've changed the look of it, so it's a different format, but it's not, I haven't changed the value. We're still talking about May 6th of 2020. Right? So it's that same kind of thing. So all we're doing is changing what it looks like, but we're not changing the value. So, but it's a very particular number one that we're going to multiply by. So we're going to use the idea that if we do a root times by the same root, that it's just the value underneath. We could think the square root of a squared is just a. So if I want to get rid of the root on the bottom, I need to multiply by the root that's on the bottom. So I'm going to multiply by root 2 on top and bottom. Well, root 2 over root 2 is just 1. So again, what we're really doing is we're really just multiplying by 1. I just have made it a very specific number 1, and it will look like a different number. So on top, remember when you multiply radicals that you do top times top, well, to multiply fractions, first of all, you do top times top over bottom times bottom. To do multiplying radicals, you do anything multiplied on the outside of the radical by anything outside the radical, and underneath the radical times underneath the radical. So that means that I'm just going to have 5 root 2. On the bottom, this really turns into 2 times 2 underneath the radical, which is really the same thing as the square root of 2 squared, which, remember, the 2 and the root can undo each other, or you can think that root 2 times root 2 is just 2. Either way, you end up getting 5 root 2 over 2. So this is what we call rationalizing the denominator. Notice that the rational numbers are numbers that can be written as fractions. So if we take a look at this number right here, 5/2 is a rational number. Right, so the 2 is a rational number. If I keep square root of 2 on the bottom, the square root of 2 is an irrational number, so that's why we call it rationalizing the denominator. Okay. Now I can have different kinds of problems as well, other than just this as a more simplistic kind of problem that we are looking at. But that's the general idea with our rationalizing, right? So if we take a look at this kind of question, we have, if I've got the square root 11 over the square root of 8, okay, what I want to do is I can simplify the square root of 8. There's actually a couple different ways that I could go about doing this, right? So if I want to simplify the square root of 8 first, if we think of the square root of 8 off to the side, this is really 2 times 4. 4 is really 2 times 2. So we have a pair of 2's and a loner 2. So that means that we end up getting 2 root 2. So I could really rewrite this as 11 over 2 root 2. Okay? So when we get that, I can multiply the top and bottom by just root 2 over root 2. Okay? I could have also chosen to multiply by root 8. I'll show you how you end up with the same thing. So on top, we get 11 root 2. On the bottom, we have 2, and then root 2 times root 2 is really root 2 squared, which, remember, the root and the radical, or the exponent of 2 undo each other. So then we really have 2 times 2 on the bottom, which is really 4. So we get 11 root 2 over 4. Right? Now, if we had multiplied by root 8, that would still be acceptable. So if we multiply by root 8, so notice here that I get 11 root 8 over 8. But notice that our root 8 isn't simplified. So then I have to say, well, this is 4 and 2, this is 2 and 2, so we have a pair of 2's. So then I get 11 times 2 root 2 over 8, and then I can say, oh, well, look, I have 2 and 8 have a common factor. 2 goes into it once, 2 goes into 8 4 times. So then I end up with 11 root 2 over 4, right? So notice we got the same answer, but I think it maybe is a little bit easier if you simplify your radical first and then just multiply by the root. Now, just so you are aware, I also could have done 11 over 2 root 2. I could have also multiplied by 2 root 2 on top and bottom. Notice that's still 1. On top, I would get 22 root 2. On bottom, I would get 2 times 2 times root 2 squared. But if we do root 2 squared, that means that those undo each other. So I get 2 times 2 times 2 on the bottom, right? Which is really 8. So we now have 22 root 2 over 8. Well, if I think about 22 and 8, 2 goes into 8 4 times, and 2 goes into 22 11 times. So then we get 11 root 2 over 4. So notice again that all three of these give you the same route, or the same answer, but they're just different ways to get there. So be aware that they can look a little different like that. So let me clear off some of this and we'll try a few more problems. So if we look at another problem, oh dear, I'm just getting used to this, and apparently my erasing skills are still not great. Sorry. Okay, so if we look at another problem, I was trying to find one from your homework. Give me just a minute. Okay, so if we look at this question, we've got 14 root 11 over 9 root 13. Okay? So it says, what's the least term that the numerator and the denominator must be multiplied by to rationalize the denominator? Okay, so this is kind of like the one that I was looking at before. I could choose to multiply by root 13 on top and bottom, but I could also choose to multiply by 9 root 13 on top and bottom. When I multiply by 9 root 13, notice that eventually I'll have to cancel out a pair of 9s. So this is why I prefer to just multiply by root 13 over root 13. Okay? So in this case, the question was, what's the least term that can be multiplied? So our least term that can be multiplied would be this one. If we were looking at our last example, you would have to multiply, you'd have to simplify the radical first and then figure out what your least term to be multiplied by would be. Okay. Now we can also get a little bit more complicated with our expressions, and I can do something like 10 root 7 minus 1 over the square root of 5. Well, it's the same pattern and the same kind of idea, it just is a little bit more complicated. So I'm going to times by root 5 on top and bottom. On the top, notice we have two things that I have to multiply to. I have to times to the 10 root 7 and I have to times to the negative 1. So on top we get 10 root 7 times 5, and I'm just going to leave it 7 times 5, and then negative 1 times root 5 is just negative root 5 all over, and then root 5 squared. Okay. Now here, the square root of 5 squared, those undo each other. Here, I left it as 7 times 5 because I want to see if I can break anything down. 7 and 5 both happen to be prime, so I can't break it down anymore. So I can't do anything to simplify this, so then it just has 10 root 35 minus root 5 over 5. Okay. Now, there are some places that would do this where you have a common root 5. So notice here that you've got this root 5. So I would get, when I take out the root 5, I would get 10 root 7 minus 1 over 5. This is not a very conventional way to write it. It is a correct way to write it because they have a common factor of root 5. But it's not one that's done very often on that. So let's take a look at this question. Okay, this one says, consider a square pyramid with a height of h and a volume of v. the length of one side of its base is given by this, where we've got square root of 3v over h. So when we're talking about a square pyramid, I am not very great with my drawing skills, so you'll have to forgive my lack of drawing skills. This one probably is there, and then that one should be dotted, but that's kind of what it's talking about. Okay, so the length of one of the sides of the base, so this is the side of the base, is given by this. So it says rewrite the expression for the length such that it has a rational denominator. Well, first of all, if we think about roots and fractions, roots as a fraction is really the square root of the top over the square root of the bottom equals the square root of, and then you write the top over the bottom. So both of these equal the same thing. So if I want to rationalize it, I'm going to use this one to help me rationalize it. Well, instead of multiplying by a number this time, we would be multiplying by a variable, right? So it's going to look weird, but it's the same kind of concept that we've been working on. So the square root of 3v over the square root of h. Well, I don't want the square root of h, so I'm going to times by the square root of h on top and bottom. Notice the square root of h over the square root of h is 1. So we get the square root of 3vh over the square root of h squared, or you can just remember that when you're squaring a square root that has the same thing underneath, that it just undoes each other. So then this would give us the square root of 3vh over h. Okay? Now, please don't make the mistake and say that this is 3vh over h and be like, oh, look, I have an h on top and bottom, so those can cancel, so I get the square root of 3v. You can't do that because this is really representing the square root of 3 times the square root of v times by the square root of h over the h. And the square root of h and h are not the same thing, so this is not equal to 1. So that's why you cannot simplify it that way. So just be cautious of that for that problem. Let me see if there's any other ones. Let's take a look at another one where we had a binomial on top. So binomial means that there's two terms, and then a monomial on the bottom. A monomial means that there's one term. So if I give you root 2 minus 2 over root 11. Okay. So if we look at this one, we have, I want to multiply by root 11 on top and bottom. Again, I'm choosing the root that's on the bottom, not on the top, because we're trying to get it out of the bottom. So then when I multiply here, you have to distribute to both of these on top. So we get 2 times 11. Again, I don't like to multiply underneath my roots because I'm going to just break it down in a minute. So you could multiply, but then you're going to have to unmultiply. So I just like to leave it as root 2 times root 11. Minus 2 root 11 over root 11 times root 11 is just 11. Okay, so I had been showing the in-between step, but if you want to get to this part now, then that's fine. So on top, notice 2 and 11 are both prime numbers, so I can't do anything. So I can just simplify this to root 22 minus 2 root 11 over 11. Again, there is, see how this has a square root of 11 and this has a square root of 11, so you could theoretically factor out a square root of 11. You could get root 2 minus 2 all over 11. Okay, this is a little bit unconventional, but it is an option that is available to be used. And I think that is most of the questions that were a bit of a struggle. Yeah, so hopefully that helps on rationalizing your denominator. You can also have a binomial on the bottom. For our purposes in our class, I'm not caring about you doing that, so I would cover that in a different video, but there is that possibility, so just be aware of that.